All right, this is for Algebra 1. This is 10C. This is what we covered in class on Tuesday, but this is for those of you that are still having a little trouble. Remember, parallel lines have the same slope, but we talked about perpendicular lines. Perpendicular lines are lines that intersect, but they intersect at a right angle, okay? So what do we know? Notice this one has positive slope, so this one's going to have negative slope. So what do we know? Slopes are opposite in sign, and they're reciprocals of one another. So I'm going to cross this out. I started this earlier. Let's pretend one of them have a slope of 3. We'll call this the slope of line 1. So let's just pretend that this line right here has a slope of 3. Then what would the slope of this line be if it's perpendicular? Well, what would be the slope of my second line? So I'm going to put a little 2 there just so I can tell that I'm talking about two different lines, two different slopes. Since this one's positive, this one would have to be negative, and the reciprocal of 3 would be 1/3. So that would be the slopes of those two lines, okay? Let's do another example. What if one of my lines had a slope, let's say, of -1/2? What would the slope of the line that's perpendicular to that be? Well, since this one's negative, this one would have to be positive. And what's the reciprocal of 1/2? Well, it'd be 2. 2 over 1. All right? Do one more. This is really important that you can find the slopes of perpendicular lines. So let me do another one right here. What if we had a line that had the slope, let's say, of 3/4? What would be the slope of the line that's perpendicular to that? Well, it has to be opposite in sign. So if this one's positive, this one would have to be negative. And the reciprocal of 3/4 is 4/3. Just flip it upside down. Okay, so keeping that in mind, I am going to pull, this is 10C. Let me write this right here. And let's look at this one together real quick. This says plot these points, -3, -5. So I'm going to go over 3, 1, 2, 3, and down 5, 1, 2, 3, 4, 5. There's that point. And we've got a +3, 1, 2, 3, -3, 1, 2, 3. Okay, so that's number 1. Number 2 says make a right triangle and determine the slope. Well, I am going to go ahead and connect these points and kind of make a line out of these. I like to be able to see it. And then I'm going to make my right triangle, because you guys are good at this, to determine my slope. So from my lower point here, here's a little right triangle. See that little 90-degree angle right there? Remember, slope is determined by rise over run. So it looks like it went up 2 and it ran 6. Okay, so my slope is 2 over 6, which will reduce to 1/3. Okay, so number 4 says to describe the line using the slope-intercept form and then give in the standard form. Well, remember, here is slope-intercept form, and you always need a value for your m and your b. So my slope would be 1/3. And my y-intercept, well, let's look at it. 1, 2, 3, 4. It looks like it's a -4. So this right here would be my equation of my line in slope-intercept form. Okay, so how do you do it in standard form? Well, I would be multiplying everything by 3 because I want to get rid of this fraction. So think about it. If you multiply this one by 3, you're going to get 3y. If you multiply this guy by 3, maybe you should show it right here, but if you multiply this one by 3, do you see those 3's would cancel, leaving you with 1x, which is this x. And you have to multiply this by 3, you would get that. So all I did is I multiplied every single thing by 3, and I did that to get rid of my fraction. So whatever's in the denominator, that's what you're going to multiply everything by. All right, it's not quite in standard form because I need to get my x, this little guy over here with the y. So think about it. If he's a positive x on this side, you're going to subtract x from both sides. So I'm going to get -x. It's a +3y, and this is a -12. Now, I think if you'll look in your answer key, they'll let you leave it like that. I'm not a big fan of this first term being negative. So if you change that sign, if you make it a positive, then you have to change the signs of everything else. So this would be a -3y. Instead of a -12, it'd be +12. So this is the way I prefer it. I'm not going to count it wrong if you do that, but I do prefer it that way. Okay, look at number 5. It says, which of the following lines is perpendicular to the line in number 4? Remember, the line in number 4 had a slope of 1/3. Remember, way up here it had a slope of 1/3. So if it had a slope of 1/3, I'm going to write this down. Then the line that's perpendicular to it, remember, it has to be opposite in sign. So if this is positive, it's going to have to be negative. And what's the reciprocal of 1 over 3? Well, it's 3 over 1, which is just -3. So look here, I can tell real quick, this has a slope of -3, so I know this one works. And what I notice is I don't have y by itself on this one, so I'm going to divide everything by 4 so that this is a 1y. And notice if I do that, these 4's cancel, so I'm going to get y equals, this is going to give me what, -3x, and that's going to give me a -1. 4 over 4 is 1. So this one, gosh, they're actually the same exact line, so obviously this one is perpendicular as well. Okay, number 6, draw a line that's perpendicular to the line given in number 4 while passing through the point 3, -3. Okay, so we're talking about, let me get a different color here. Here's the point 3, -3, and we want it to be perpendicular. So we want it to be going right here, okay? Remember, if it's perpendicular, it's going to have a slope of -3. If you want to think about that as a fraction, you're going to rise 3 and run 1 to the left, since it's got a negative. So I'm going to rise 3, 1, 2, 3, run 1 to the left. I'm going to do it again. Go up 3, 1, 2, 3, run 1 to the left. I'll do it even one more time. 1, 2, 3, 1 more to the left. So there it is. This is a line that's perpendicular to my other line. Remember, what it means to be perpendicular is they intersect at a right angle. So you can kind of see right there. Okay. All right. Number 7 says, describe this perpendicular line with a slope-intercept form. And then we'll probably have to put it in the standard form. So remember, this is slope-intercept form. How are we doing on time, by the way? Okay. So you have to have values for these two. So your slope is, we already discussed that, it had to be -3. And look what your y-intercept is. Come back up here to your graph for a minute and see what your y-intercept is. It's 1, 2, 3, 4, 5, 6. It's a +6. So that should be your equation right there. Okay? Make sure you can see that. Okay, let's try another one right here. Look at this. It says draw a line that's perpendicular to the given line in number 4. We're going to do it again, but this time it's going to pass through the point 0, -4. Look at, I'm going to go back up here to my graph. Look at the point 0, -4. 1, 2, 3, 4. It's going to go through that point, and it's going to be perpendicular. So again, it's going to have the same slope as this one. So it's going to have a slope of -3. So I'm going to go up 3, 1, 2, 3, and to the left 1. Do it again. 1, 2, 3, to the left 1. So you can see I've got this line right here. You can see they're perpendicular. Okay? Guess what these two are? Parallel. They both have the same slope of -3. That's kind of cool. Okay. So that's number 8. Number 9 says describe this new line with a slope-intercept form. Okay. Well, again, here's slope-intercept form. Have to have those two values. My slope, of course, is still -3. Don't forget to write your x. And the y-intercept, remember right here, can you see that right there? They told me, you can either tell by looking at this point, or you can tell by looking at the graph, but that is your y-intercept. So we're going to come over here and just say, -4. So that's your equation. They want that in standard form. This one's actually nice and easy to put in standard form, because all you're going to do is take this x, throw him to the other side. If it's a negative on this side, on the other side it's going to be positive, so you're going to end up with 3x plus y, still a -4. So this is standard form right there. Okay? Number 10 said, what did you notice about the slopes of the lines you drew? Well, they're the same, right? So therefore they're parallel. All right, I'm going to look at just one other thing real quick here. Just a minute, I'm flipping to the right page. Actually, that should probably be enough. So we'll stop there.